this is Miss Hodges, and this is Wonderful Waves. Energy travels in waves. So now we're going to learn about how the energy moves through these different types of waves. Wave motion is a disturbance that travels through space and time. The wave motion is what transfers the energy from one point to another. Waves always begin with a vibration which sends energy through a medium. The medium is the object that the energy is traveling through. There are two classes of waves. The first is the mechanical wave. They always have to have a medium. They've got to have something to travel through or they won't move. They can be transverse in shape or compressional. Ocean waves and sound waves are examples of mechanical waves. The other kind are electromagnetic waves. These waves can travel through empty space in a vacuum. They are always transverse in shape. Visible light, microwaves, X-rays, infrared, radio waves, TV waves are all examples of electromagnetic waves. There are two types of waves. The first is the motion. The motion of the medium is perpendicular to the motion of the wave. The energy is traveling from here to here, but the actual wave is going perpendicular or at right angles to the direction of the energy. So it looks like it's going up and down. This is like when you see people doing the wave at a ball game. The compressional waves, the motion of the medium, is parallel to the motion of the wave. So the energy travels in this direction, and so does the actual wave. And you have squishes and spreads, also known as compressions and rarefactions. A transverse wave travels through a snaky. It'll have crests and troughs, which are the hills and valleys of the wave. The distance between each crest, from crest to crest or trough to trough, is called a wave length, or literally the length of the wave. This is a snaky. A compressional wave travels in the same direction as the energy and will go through in compressions. The darker spots show where there's a compression. Transverse waves. The wave is moving in one direction and the actual wave will go at perpendicular angles to the direction of the energy. You have the crest, which is the top, the trough, which is the bottom, and the amplitude is the height of the wave. The wavelength is the length of the wave. Compressional, also sometimes called longitudinal, the motion of the medium is parallel to the motion of the wave. If the energy is going in this direction, so is the wave. Again, your compressions or squishes are usually seen darker, and then the distance between the two compressions, the spread out part, is called the rarefaction. Mechanical waves can be transverse or compressional. Remember, mechanical waves must have a medium. The transverse wave on the left is the ocean wave, where the energy goes up and down. The compressional wave on the right is a sound wave, where your sound waves are compressed and spread out as they travel through the air. Electromagnetic waves are always transverse. Remember, they can travel through anything, including space, like a vacuum. The visible light is always in a transverse wave on the left, and then sometimes you have invisible light that also travels transverse. In this picture you see where they've used an X-ray, which is a type of electromagnetic wave, to take a picture of the bones inside someone's body.